Dear conference organizers, thank you for the opportunity to present a report. Dear colleagues, we bring to your attention a report on the topic, the use of digital technologies for flipped learning implementation. The authors of the study are Oksana Klochko, Vasyl Fedorets, Svitlana Tkachenko, Olena, Maliar. The research presents the study of the use of digital technologies for flipped learning implementation. The use of flipped learning based on digital technologies requires thorough development of the virtual learning environment, a detailed selection of the study content and its adaptation to the concrete group of students. The purpose of the research is to describe the aims, content, and ways of broadening the flipped learning possibilities with the application of the virtual learning environment and machine learning. So nowadays, we cannot imagine the field of education without the use of digital technologies in the educational process. With the appearance of virtual learning environments, we may observe a rapid accumulation of educational data. In modern conditions, a society requires educational services that follow the principles of student-centric education, thus making the student a central figure of the teaching process. In the course of implementation of these principles, the most popular mixed learning model is the flipped learning model. The innovative and personalized nature of flipped learning may be provided with the help of virtual learning environment, which is a methodological condition for raising a student's interest in learning, activating their study process, revealing their cognitive and personal potential, as well as developing digital competences, independence, and individuality. Also, I must admit that flipped learning is a form of learning which allows change the traditional educational process in an innovative and personally oriented way, corresponding to the competence paradigm, which is based on the idea of practical applicants of the knowledge. Accordingly, the learning process is formed on the basis of the following system organizing components. The student's homework is to watch the videos with the study materials of the next lesson. The students cover the theoretical material on their own, and the study time in class is spent on doing different practical tasks. So the flipped learning techniques presuppose a combined form of traditional and e-learning using the VLE tools. The figure 1 presents a structural model of the scientific methodological system of teaching students the topic geometrical transformation based on flipped learning with the use of machine learning techniques. According to some personality-oriented approach, the student as a subject of the educational process occupies a central place on this model. The following blocks were singled out as the other interrelated elements of the scientific methodological system: target, content, methodological organizational activity, diagnostic comparative with the use of machine learning tools. This model is designed on the basis of the system approach. It is an open, dynamic system and it interacts with the educational space. The study of the introduction of the flipped learning method with the application of VLE was conducted on the example of studying the subject of geometry, the topic geometrical transformation in the 9th form. In order to implement flipped learning, an educational website, geometrical transformation was developed. It contains a system of various methodological developments that the teacher may use to work with students while studying the topic geometrical transformation. For example, a topical plan, multimedia presentation, lesson drafts, tests, etc. Let us look at the components of the geometrical transformation website, which was used in the course of the study. First of all, a topical plan highlights a sequence of subtopics, which needs to be mastered in the course of studying the stated topic. The theoretical reference guide section contains a multimedia presentation on the topic as well as some useful links. The lesson draft section contains material for every subtopic: motivation of the student study activity, preparation tasks for forming the conceptual framework and typical cognitive themes, task for consolidation of the knowledge, and task for laboratory works, task for ensuring the formation of key competences, and cross-topic references, test tasks project tasks. The problem books contain problem books, training videos, and games, which could be used while studying the given topic. And defining the organizational pedagogical conditions which are needed for successful students studying on the topic geometrical transformation with flipped learning with the application of ELE, we took into consideration a lot of different aspects. The list of them you can see on a slide. But we also conducted a survey among teachers and students in order to realize what conditions are the most essential among the others. The conditions with the majority of the points are forming positive motivation among the students towards studying the topic geometrical transformations, using flipped learning, the use of flipped learning in order to form the necessary competences in students, and also the use of current digital educational tools and techniques, for example, educational websites. We got such a result because the other conditions are also important, but they are not so defining. Let's now talk about the research. The first stage of the research was sustaining. The purpose of this stage was to study the state of the researched problem and define ways of solving it. The research was conducted on the basis of the 9th form of general unity secondary education institutions. The number of students involved in the research was 41. Pupils of 2 classes took part in the experiment. The number of students were 20 and 21 in each class, which we selected as a control and experimental groups, respectively. At the ascertaining stage of research, the questionnaire method was applied, which allowed us to clarify the organizational conditions of studying the topic geometrical transformation using flipped learning with the application of ELE. The second stage of the study was exploring. At this stage, flipped learning using ELE was applied for studying the topic geometrical transformation. This stage included searching for, analyzing, and testing ELE tools and flipped learning techniques with the application of machine learning methods. The students passed the test several times in order for us to determine the ways of adapting the study content to certain groups and students according to their achievements. The purpose of the last forming stage of the research was the assessment of the efficiency of the developed teaching methodology on the topic geometrical transformations using flipped learning with the application of ELE. In order to carry out the forming stage of the research, the controlled and experimental groups of students were taught within the general secondary education institutions in accordance with the defined organizational pedagogical conditions. The control group was taught using the traditional methods and methodology. The experimental group using flipped learning with the application of ELE. To compare the results and achievements of the students of the control and experimental group, we used a Wilson-Mann-Whitney test. The theoretical and empirical value of this criterion are calculated by the formula you can see on the slide. To detect typical students' mistakes in order to adapt the components of the scientific methodological system of teaching students with using the flipped learning method based on ELE, we applied such clustering machine methods as canopy, expectation maximization, and furthest first on the basic of the workup platform. The general parameters you can see on the slide. Tests which pupils had to pass consisted of 10 tasks, and for the first 8 tasks, they could receive 8 marks, 1 mark per task, and for the other 2, maximum 4 marks, 2 marks for each task. The result of the ascertaining stage of the research has shown that the average level of preparation of students in geometry at the start of studying the topic geometrical transformation in the control and experimental groups were relatively homogeneous and was 6.8 and 6.5 points respectively. The analysis of the research results showed that after studying the topic geometrical transformations using flipped learning with the application of VLE, the experimental group demonstrated generally positive dynamics. As it's been already said, in this research we use clustering methods of machine learning in order to adapt the components of the scientific methodological system of studying the topic geometrical transformations using the flipped learning method based on VLE. Mostly we wanted to determine the main typical mistakes which are common in process of studying the chosen math topic. The first algorithm which we used was expectation maximization. There are 25 objects in the first cluster, 66 in the second, 47 in the third, and 77 in the fourth. Objects of the first cluster are the students whose overall mark for the test approximates 3. Objects of the second cluster are the students whose overall mark for the text approximates 10. Objects for the third cluster are the students whose overall mark for the text approximates 6. And object of the fourth cluster are the students whose overall mark for the test approximates 7. Objects of each of the classes are united by the fact that most of them have made a mistake in tasks 9 and 10. The second algorithm was the canopy algorithm. We got 106 objects in the first cluster, 30 in the second, 25 in the third, and 54 in the fourth. Objects of the first cluster are the students whose overall mark for the test approximates 11. Objects of the second cluster are the students whose overall mark for the test approximates 8. Objects of the third cluster are the students whose overall mark for the test approximates 3, and objects for the fourth cluster are the students whose overall mark for the test approximates 6. Objects of each of the classes are united by the fact that most of them made a mistake in task 10. The last algorithm was the furthest first algorithm. We have 52 objects in the first cluster, 7 in the second, 138 in the third, and 18 in the fourth. Objects in the first cluster are the students whose overall mark for the test approximates 5. Objects of the second cluster are the students whose overall mark for the test approximates 2. Objects of the third cluster are the students whose overall mark for the test approximates 9. And objects of the fourth cluster are the students whose overall mark for the test approximates 3. Objects of each of the clusters are united by the fact that most of them made a mistake in tasks 9 and 10. As a result of using all three clustering algorithms, we may make an overall conclusion that most mistakes were made in tasks 9 and 10. This refers to both groups. So finally, I want to conclude that in the course of the research, we determined the organizational pedagogical conditions for implementing the flipped learning method using virtual learning environments, analyzed the advantages of using such a technique at schools, and proved its efficiency. The theoretical and practically significant generalizations concept proposal formulated in the research may be used for improving the quality of educational and broadening possibilities of the educational landscape. In the scientific research field for further scientific practical developments in the stated field, in the course of designing and using virtual learning environments in the educational process. Thank you for your attention.